So this question is coming from October-November 14, paper 3 variant 1. And this is the 8th question of the paper, where the unusual type of question that I wanted to show you is the second and the third part of this question. If you ask me honestly, P3 trigonometry is just easy if you follow all the key pointers that I had explained to you in one of the previous video in this series. And yeah, it's pretty easy. And that is why if you look into the list of the unusual question, there is only one question that I've mentioned. After this, you can see directly differentiation is starting. The reason behind this is P3 trigonometry is pretty easy if you keep all these key pointers on your fingertips and if you are having luck in your favor. On any random day, you might be out of luck and even the simple question, it might not click to you. So yeah, it's just a matter of practice. You keep up with the practice. And let's say if you're struggling with any kind of questions, you can let me know in the comment section. I can surely reach out to you and help you with respect to the same. But yeah, over here in trigonometry as such, there is not a very difficult kind of question that I could have found, but here is one of the unusual questions in my opinion. So let's go ahead and start dealing with the second and the third part. The first part is pretty straightforward. You just need to open this with the help of sine A plus sine B formula and then convert sine to theta and cos to theta in the format of only sine theta. And eventually you will getting this by simplifying it. So let us directly look into the second part of this question, which is asking us to prove or show that after making the substitution, wherever you are seeing x, if you substitute 2 sine theta over root 3, we can convert the entire equation in the format of sine 3 theta is equal to 3 over 4. Now the reason I called it as an unusual question is because only for 1 mark you need to prove this. So that is why you will need to do slightly more steps as compared to what you usually do on your 1 marker question. So that is why this is slightly unusual. But let me show it to you that if I had to do this, how I would have done this. Just note that sine 3 theta is something that is also given to you in the first part. So by doing the substitution, if you're able to get something like this, if you're able to get something like this format, then of course converting that into sine 3 theta will not be a problem. So let us go ahead and try to solve the second part of this question. I know that x is equal to 2 sine theta over root 3. And if I take cube of this, I can just write that x cube over here will be equal to 8 sine cube theta divided by what is the cube of root 3? It is, let me just go ahead and do this in the calci only so that I am not keeping any kind of chance to do silly mistakes. 3 root 3. And what is my x? Of course, x is just 2 sine theta over root 3. So I can substitute this x cube into this equation so that it looks like 8 sine cube theta over 3 root 3 and then minus x. So minus x will be 2 sine theta over root 3 and at the end minus root 3 over 6. This is equal to 0. Now how can I simplify it so that I am able to at least get this format so that I can replace it with sine 3 theta. Over here, my first thing is let us get a common denominator of 3 root 3 and then send it to the right hand side so that it can be simplified. So for the first term, let me just change the color back to blue. So it is going to be 8 sine cube theta, then minus 6 sine theta. And then over here, I'm going to multiply 3 root 3. So it's going to become 9 over 6 is equal to 0. Of course, the common denominator, I've shifted it to the right hand side. You can see that just for a 1 mark, we are doing a lot of steps. That is why unusual question. Now over here, what I can do is I can divide the whole equation by 2 so that I can get this format. I'll get 4 sine cube theta and also 3 sine theta if I divide this equation by 2 and also multiply it with a negative sign so that its sine cube is going to have a negative coefficient basically. So it's going to become minus 4 sine cube theta plus 3 sine theta and then plus 9. Okay, yeah, I did a mistake over here. There had to be a plus over here. So yeah, 9 over 6, but then I'm also dividing it by 2 with a negative sign also. So let me fix this very quickly. So it's going to become 9 over 12, which is equal to 0. Now I can clearly see that on the left hand side, it is 3 sine theta minus 4 sine cube theta as I wanted. So that is my sine 3 theta. And this is equals to 9 by 12. So 3 3s are 9, 3 4s are 12. So it is equal to 3 by 4. And this is what we have proven. So yeah, for 1 mark, If you ask me, I would do all these kind of steps. I'm not sure if there is any kind of an easier approach out there, but if you are able to come out with an easier approach than this, let me know in the comments. But yeah, we are done with the second part. Let's think about the third part, where third part is one of the question where student just cried a lot that I am not able to understand this. If you are someone who is having good understanding of ASTC diagram, then I don't think so that it would be that troublesome. But yeah, let's go ahead and try to solve this. Let me first clear the screen over here for us and move on to the next part. So in part 3, we are supposed to solve this cubic equation. Now cubic equation can have three different roots. There could be two complex, one real, or all three real roots. So in that case, what can I do over here? I know that sine 3 theta is equal to 3 by 4 is nothing but this equation only. So I can utilize this information because the question is using the word hence. So I need to utilize answers from the previous part or the question from the previous part. So I'm going to first of all find the value of theta. I'm going to find the value of theta with respect to which I can then plug it over here and get the respective value of x. It looks pretty simple, but I'll tell you where is the problem. So I'm going to solve sine 3 theta is equal to 3 by 4. So I'll solve for all the values of 3 theta. There is no domain given over here. And that becomes the biggest issue for the students, that what am I supposed to do? So yeah, let us go ahead and try to understand this with the help of ASTC diagram. My sine 3 theta is having a positive value. So it means that I am in my first quadrant or the second quadrant where my sign is positive. Now I can see that this is my one solution, this is my another solution. So I'll get two solutions out of this and I can solve for theta and then I can substitute it back into this equation and find the respective value of x. But then that will be only two solutions. How will you get third solution? We'll talk about that. Let us first get two solutions out of it. So 3 theta is equal to what? It will be the first solution is sine inverse of 3 by 4 and the second solution is 180 minus sine inverse of 3 by 4. So sine inverse of 3 by 4 and 180 minus sine inverse of 3 by 4. So it does not really matter if you convert this into degrees or radians because at the end you are utilizing your sine of an angle. So if you are keeping your calc in degrees mode, solve it in degrees mode. If you are keeping your calc in radians mode, keep it in radians mode. Simple as that. So over here my theta will come out as, let me use my calc directly. So sine inverse of 3 by 4 is 48 and also I'll need to divide this by 3. It's 16.1967 dot dot dot. And the second value over here is 180 minus sine inverse of 3 by 4. And then I'll divide this value by 3. That is 43.80320. 80320 dot dot dot. Now, the moment I got the value of theta, let me find out the value of x. So I'll try to find my value of x over here by substituting 16.1 over here. So let me do this. 2 sine of angle, which is 16.1967 divided by root 3. So the value of x that I've got over here is 0.322. 0.322. And we are supposed to give our answers correct to 3 SF. So yeah, this looks good. The second value of x I'll be getting by putting 43 degree inside this. So 43.80320. Why am I using a lot of decimal places? So I am avoiding the rounding of error. I am getting 0.799 over here. Now, how would you find the third value? That is where students are confused. Apart from, okay, what is the domain? So let's say if I wanted to find the third value of 3 theta, what would I have done? I would have gone 360 plus sine inverse of 3 by 4 and then divide that by 3 and then put that into this equation and then see what is the answer. So in that case, you will see that your answers are going to repeat over here. You can try it over here along with me. Let's say I'm going to find my third angle over here, which is going to become 360 plus sine inverse of 3 by 4. And if I do this, I'm getting this answer. If I divide this by 3, I'm getting 136.1. Now I'm going to plug this into this equation. 2 sine of answer divided by root 3. And you are seeing that I'm getting 0.799. Now if I repeat this process for the second angle also, where I know that in place of answer theta, I need to do divide by 3, and on the top I'll be having 360 plus 180. I'm just adding 360 to this angle basically. So let me do this in my calci. 360 plus 180 minus sine inverse of 3 by 4. And yeah, I think if I press answer, you are getting 0.322. So now students are thinking that there are only two solutions. But then if you just are being a smart guy, if you go to your mod 5 and 4, that is a cubic calculator, if you put A as 1, B as 0, C as minus 1, and C as square root of 3 by 6, and if you look into your solutions, there is minus 1.12, 0.799, and 0.322 as your solution. So clearly you can see that there are three solutions that you must have got. And because one solution is negative, what you could have done is that you could have gone into the negative domain. Okay, the clockwise moment of the angle is nothing but a negative value. What is this angle? This angle is going to become 3 theta is equal to a minus of 180 plus sine inverse of 3 by 4. I know that this angle is sine inverse of 3 by 4, so 180 plus sine inverse of 3 by 4. And because I'm going in the clockwise direction, there is a negative value. So this is my third value of 3 theta. After this is my third value. So from here, I can find the value of theta as 1 by 3 of this value. Okay, and of course, once I get this value of theta, I can put it into this equation and let's see if it's going to work. So mode 1, I'm going to get minus of 180 plus sine inverse of 3 by 4. You can see that this was quite some unusual question. I'll divide this by 3. I got theta value as minus 76.1. Now after this, what I can do is I can put this to sine answer divided by root 3. You see, we got minus 1.12 as the third solution as we had seen in our cubic calculator. So let me go ahead and put this over here that my third value is minus 1.12. Of course, you can show the steps over here that the third theta or the third value of the 3 theta is this. And after that, you are writing the next value over here by dividing it with 3 and finally putting it back into this equation. And yeah, this will be your 3 answers correct to 3SF as mentioned in the question. And you are done with this question. Now, one more thing I would have liked to point out over here is if you had gone 360 plus this angle and 360 plus this angle, if this was not working, what you could have also done is you could have gone 720 plus this angle or 720 plus this angle. I am sure one of this angle must be giving your answer corresponding to minus 1.12 because of course I know that the sine cycle is a repetitive cycle. So your answers will just keep on oscillating. So yeah, you must get your answer even if you're going in the forward direction, that is in the anti-clockwise direction. But yeah, you will just need to do slightly extra steps over there as compared to what you have done over here. So yeah, this question is unusual because you were not given a domain. You just had to use your presence of brain and ASTC diagram to solve this question.